This video is prepared based on historical records and scientific sources. History is often told through kings, wars, and empires. But the people who truly reshape the world are not always those who sit on thrones. Sometimes, the greatest revolutions begin in silence, at a desk, inside a mind that refuses to accept easy answers. This is the story of Isaac Newton. In the 17th century, humanity tried to understand the universe with limited tools and incomplete ideas. The sky was mysterious. Motion was poorly explained. Nature appeared chaotic, almost arbitrary. Newton rejected that assumption. He believed the universe was not random, only misunderstood. What made Newton extraordinary was not just intelligence, it was dissatisfaction. He refused to accept explanations simply because they were traditional. When an apple fell from a tree, most people accepted it as ordinary. Newton asked a different question. Why does it always fall downward? That question may seem simple, but history shows that progress often begins with questions others ignore. Through this curiosity, Newton formulated the law of universal gravitation. For the first time, nature was described not as a mystery but as a system governed by rules that could be measured, calculated, and predicted. This idea was revolutionary because it united the heavens and the earth under the same laws. The motion of the moon and the fall of a stone were no longer separate phenomena. They were part of a single structure. Newton did not invent the universe. He gave humanity a language to understand how it works. His laws of motion answered questions that had puzzled thinkers for centuries. Why objects remain at rest, why they accelerate, why they change direction. These principles remain valid today. They still form the backbone of engineering, mechanics, and space exploration. What matters is this: Newton achieved this without modern technology. No computers, no satellites, no advanced instruments. Only observation, mathematics, and relentless discipline. His book, Principia, became one of the most influential works in human history. It declared that nature follows order, not chance. But Newton was not a perfect hero. He was difficult, private, uncompromising. Scientific progress does not always come from agreeable personalities. It often comes from people unwilling to retreat. Newton saw science not as a career, but as responsibility. When ideas were flawed, he challenged them. When explanations were weak, he replaced them. Modern civilization still stands on the foundation he built. Every bridge that holds, every satellite that stays in orbit, every spacecraft that reaches its destination, behind all of it, Newton's equations are still working. That is not coincidence. That is the power of solid foundations. Newton's true legacy is not just what he discovered, but how he thought. He assumed that nature had structure, and that this structure could be understood. That assumption defines modern science. Where tradition once accepted mystery, Newton demanded explanation. He shifted humanity from superstition to cause and effect. In doing so, he stripped the universe of magic and replaced it with meaning. Newton reminds us of a hard truth. The world is not changed by those who speak the loudest. It is changed by those who think the deepest. Have you ever wondered about the man who saw an apple fall and unlock the secrets of the universe? Today, we're diving deep into the life of a true giant of science, Sir Isaac Newton. This isn't just a story about gravity. It's a tale of revolutionary ideas, bitter rivalries, and a mind that reshaped our world forever. Born prematurely in 1642 in a small English village, Newton's early life was far from easy. He was a quiet, introverted boy, often lost in his own thoughts and inventions. His school reports called him idle and inattentive. Little did they know, this quiet boy would one day speak a new language of the universe. When Cambridge University closed due to the plague, Newton returned home. It was during this period, his year of wonders, that his genius truly ignited. It was then that the legendary apple supposedly fell, sparking his thoughts and gravity. But that was just the beginning. In his solitary study, Newton also began to unravel the mystery of light. At the time, everyone believed white light was pure and colors were modifications of it. Newton thought differently. Using a simple prism, he passed a beam of sunlight through it, splitting it into a beautiful rainbow of colors. But he didn't stop there. he used a second prism to recombine those colors back into a single beam of white light. This elegant experiment proved that white light is not pure, but a mixture of all the colors of the spectrum. This discovery completely changed our understanding of light and optics, and it led him to invent the reflecting telescope, which uses mirrors instead of lenses to avoid color distortion, a design still used in major observatories today. But perhaps Newton's most powerful creation was a new mathematical tool. He needed a way to describe and calculate change the speed of a falling apple, the curve of a planet's orbit. Frustrated with the limits of existing math, he invented his own, the method of fluxions. Today, we know it as calculus. It gave science the language to describe motion and change, becoming the bedrock of physics and engineering. However, Newton wasn't alone in this discovery. Across the Channel in Germany, another brilliant mind, Gottfried Wilhelm Leibniz, had independently developed his own version of calculus. What followed was one of the most famous and bitter rivalries in scientific history. Both men, backed by their supporters, accused the other of plagiarism. The dispute raged 4 years, dividing the scientific community. While we now recognize that they both developed calculus independently, the controversy cast a long shadow over their lives. It's a powerful reminder that even the greatest minds are human, driven by pride and ambition. Beyond the ivory tower of academia, Newton had another, surprisingly different, career. In 1696, he was appointed Warden of the Royal Mint in London. This wasn't just an honorary title. At the time, England's currency was in crisis, with widespread clipping and counterfeiting. Newton threw himself into the job with the same intensity he applied to science. He became a master detective, personally going undercover in taverns and hideouts to gather evidence against criminals. He prosecuted counterfeiters with ruthless efficiency, reforming the entire currency system and stabilizing the nation's economy. It shows a side of Newton we rarely hear about, not just a thinker, but a man of action. In his later years, Newton was a celebrated figure, president of the Royal Society and a knight of the realm, but he never stopped questioning. He spent countless hours on alchemy and biblical studies, searching for deeper truths about the world. When he died in 1727, he left behind a universe that was profoundly different from the one he was born into. His masterpiece, the Principia Mathematica, laid out the laws of motion and universal gravitation, giving humanity a rational, predictable framework for the cosmos. For the first time, the same laws governed the fall of an apple and the orbit of the moon. Newton's legacy is immeasurable. His scientific method based on observation, experimentation, and mathematical proof became the gold standard. He provided the intellectual toolkit for the Enlightenment, inspiring thinkers to apply reason to all aspects of life, from politics to philosophy and modern physics. From the rockets that take us to space to the technologies that power our digital world, stands firmly on the foundations he built. Isaac Newton showed us that the universe is not a chaotic mystery, but a puzzle that can be understood through reason and curiosity. He taught us to look at the world, ask why, and not rest until we find the answer. His story is a testament to the incredible power of a single human mind to change the world forever. Don't forget to subscribe to our YouTube channel and click the bell button to be notified of updates.